Good day everyone. So today we're gonna talk about stoichiometry, specifically the topic writing and balancing chemical equations. So first we must need to know the parts of chemical equation. Here we have a sample H2 plus O2 yielding to H2O. First is our reactants. Reactants are elements or compounds before a chemical reaction. They are usually found on the left side of the equation. So in our sample, we have H2 and O2 as our reactants. Chemical reaction can be portrayed by this arrow. Now, the products. Products are located on the right side of the equation. They are the outcome of a chemical reaction. In our case, we have H2O as our product. Next are the subscripts. They are the numbers here in pink. So subscripts tells us the number of atoms of each element. So here we have hydrogen, it has 2 atoms, oxygen with 2 atoms as well. Now the coefficients. These are the number located before an element or a compound. So they are used to balance the number of atoms on each side of the equation. Finally, we have the state. We have the small letters located just beside the subscript. They tell us in which state the element is. So here we have the hydrogen in gas state, water in liquid state. The other one is solid, which is represented by letter S. Now, steps for balancing an equation. First is translating the statement. A lot of students commit mistakes here, so we need to be careful with it. A magnesium strip burns in oxygen gas to yield powdery magnesium oxide. So if we're going to look, magnesium and oxygen are combined and then they produce magnesium oxide. So magnesium and oxygen will be our reactants, while magnesium oxide will be our product. So magnesium is Mg, oxygen is O with a subscript 2, and then magnesium oxide is simply MgO. Next step. Before that, I will give you a tip. Be sure to be familiar with the periodic table. It will be easier for you to locate elements if you know how the periodic table is arranged. So, aside from that, also be careful with the diatomic elements. Those are elements that doesn't exist as a single atom in nature. So, an example earlier is oxygen. Oxygen in periodic table is simply O, but why do we put subscript 2? Since it is a diatomic element. Oxygen atom finds another oxygen atom and bind with them. So that's why we need to put a subscript 2. And also, you need to be familiar with the polyatomic ions and the organic compounds, for they will be also used in chemical reactions, and some teachers don't include their molecular formula, so you need to be familiar with it. Next step is balancing the atoms. The first thing you need to do is locate which substance is the most complex. So in our case, we have the magnesium oxide since it is a compound. So we're gonna put a coefficient, and I will choose 1 for it is easiest. So 1 MgO. Now that we have 1 as our coefficient in magnesium oxide, we're going to balance the elements to the reactants. So first I'm going to Mg. So I'm going to put a coefficient that would be an equal to the product. So I have 1 Mg on the product, so I need to put 1 also here. So now we have a balanced number of magnesium atoms. Next would be the oxygen. In the product, I have 1 oxygen atom, but on the reactant, I have 2 oxygen atoms. I need to find a coefficient that would be multiplied to 2, that will give me 1, and that is 1/2. The third step is adjusting the coefficients. It would be much more convenient if every coefficient that will be seen is whole numbers. So how do we get rid of this fraction? simply by multiplying the denominator in the whole equation. So the denominator here is 2. We're going to multiply the whole equation by 2. So now we have the new equation 2mg plus 1O2 yielding to 2mgO. Fourth step, checking. So on our reactants, we have 2 Mg atoms, and then oxygen atoms times 2. That would be 2 oxygen. On the product, we have magnesium times 2. That will give us 2 magnesium atoms. Oxygen times 2 will give us 2 oxygen atoms. As we can see, the numbers are equal. So, meaning we balance the equation. Final step is specifying the states of matter. So, we're going to put if they are in solid, gas, or liquid state. Earlier, it was stated that magnesium strip, so meaning magnesium is in solid state. Then it was formed with oxygen gas, so oxygen is in gas form. And then they yielded and formed a magnesium oxide, which is powdery. So, meaning the magnesium oxide is solid, and that's how we get our answer here. So now we're going to apply what we have learned. Here I have a problem that states that within the cylinders of a car's engine, the hydrocarbon octane, one of the many components of gasoline, mixes with oxygen from the air and burns to form carbon dioxide and water vapor. Write a balance equation for this reaction. So we're going to look what are the elements and compounds. So here I can see hydrocarbon octane, oxygen, carbon dioxide, and water vapor. And in the problem, it states that hydrocarbon octane was mixed with oxygen and then they form carbon dioxide and water vapor. So if I'm going to write a chemical equation, I'm going to put hydrocarbon octane and oxygen as my reactants, while my product will be carbon dioxide and water vapor. So if I'm going to write it, this is how it's going to look like. I have the hydrocarbon octane and oxygen on the left side since they are reactants, and carbon dioxide and water vapor on the right side. So now, second step, we're going to balance the atoms. So here I'll just put the atoms and the elements and the number of atoms respectively so I can see my progress. So, carbon has a hydrogen 18, 2, 1, 2 plus 1, 3, hydrogen 2. So we're going to choose what is the most complex compound. So for me, the most complex is hydrocarbon octane. So I'm going to put a coefficient. I'm going to put 1 since it will be easier. Since I have now put a coefficient to hydrocarbon, I'm going to balance it, the number of atoms on the other side. So octane has carbon and hydrogen. I'm going first with the carbon. So carbon on our reactant has 8 atoms, while on product is 1. So I'm going to get a number when multiplied to 1 will give me 8. So that would be easy, 8. Now as I put coefficient to carbon dioxide, carbon will not just be affected but also the oxygen. So the number of atoms of oxygen will also change. So 8 times 2 will give me 16 plus 1 here will give me 17. Now going back to octane, I can see hydrogen element. So I'm going to look for hydrogen in the product. So water has hydrogen. It has a subscript 2. So I'm going to find a coefficient that will multiply to 2 will give me 18. So that will be 9. Then 9 times 2 will give me 18. Now I have a balance C and H. Now as I put again coefficient in H2O, the oxygen atoms changes again. So from here, 8 times 2 will give me 16, plus 9 will give me 25. Now last, I only have oxygen left to balance with. So I'm going to find a number that when multiplied to 2 will give me 25. But that would be impossible since any number multiplied by 2 will give me even. So that will give me an idea that I have to put fraction. So I'm going to try 25 over 2. 25 over 2 times 2, it will cancel the 2's and it will give me the whole number, numerator 25. So that will be 25. Now, third step, adjusting the coefficients. So here again, we have fractions. So to make things easier and more convenient, we need to remove the denominator to make it a whole number. So here we have 25 over 2, the denominator is 2, so we're going to multiply the whole equation by 2. And now that will give us 2 octane, 25 oxygen atoms, 16 carbon dioxide, and 18 atoms of water. So now if we're in doubt, we're gonna see again if we have the right number. So now we're going to check again. So I have here 2 times 8, that will give me 16. 2 times 18 will give me 36. 25 times 2 will give me 50. 16 times 1 will give me 16. 16 times 2, that would be 32 plus 18. Here, oxygen will give me 50. And then hydrogen, 18 times 2 will give me 36. So, you can say that we have now balanced it. So, for our final step, that will be stating the state of each element. So, in our problem earlier, we have the octane as a component of gasoline. So, meaning our octane is in liquid form. And then oxygen was in gas form, so G. Carbon dioxide also in gas form, while water vapor, so water in gas form. So now we have our final answer.